Week 4, lesson 7. All right, so those of you that had me last year, we did do tree diagrams before. Those of you that didn't have me, I don't know if you did tree diagrams. So these are two really, really good visuals for you to look at. And you can also get to see sort of the difference between what an independent one looks like, meaning that each branch sort of looks the same as the previous branches because nothing has happened previously to change the subsequent branches, right? Whereas here, the one that's dependent, since it's not replaced, notice that this fraction, let's say, is different than this fraction. Whereas on the top one, you can see that these are the same. Okay, so let me erase some of these highlighting things because they're annoying. Okay, so now that you've kind of read those over, I want to point out some things, okay? I want to point out that on any branch that you pick, if you add those up, you get 1. If you add those up, you get 1. If you add those up, you get 1. Even at the very, very far ends of the branches, if you add those up, you get 1, okay? And if you're wondering, well, where did they come up with this number? You get it by multiplying along the branches. If you multiply these numbers, you'll get that pink one there at the very, very end. Likewise, this one you get by multiplying these two, right? This number you get by multiplying those two, etc. Okay, so again, let me erase some stuff that's sort of in my way. All right, so again, you can kind of read over, convince yourself the independent versus dependent, what they look like. All right, so now let's take a look at this example. Okay, so we have the probability that a train is late is 0.3. So let me start a tree diagram here. We could have the train being late, or we could have the train being on time. Okay, so I'm just using some abbreviations. If this is 0.3, this over here has to be 0.7 because every branch always adds up to be 1. Okay, next, it says if the train is late, so I'm looking up here at the top branch, the probability that Joe will not make it to work on time is 0.6. Okay, so not make it to work on time, in other words, means Joe is going to be late. And that is 0.6, which means that this one then has to be 0.4. Okay, and then if I continue to read, if the train is not late, so now I'm down here, right, that's the train being on time, the probability that Joe will be on time, Joe on time is 0.9, which means that Joe late is 0.1. Okay, once you've got the tree completely filled out, now it's just a question of where do I find my answers on this tree? So let's kind of take these one at a time. Let's look at question A. Find the probability that the train is late and Joe is on time. Train is late, that's here, and Joe is on time. Does that make sense? You follow the branches to answer that question, and then you just multiply along the branches. 0.3 times 0.4 equals 0.12. Excuse me. All right, let me switch colors. For B, the probability that Joe is on time. Well, that can happen two different ways. Correct? It can happen here, Joe's on time right here, but Joe's also on time here. Okay, so let's figure out those two branches and then add them up. Okay, so this branch, the top one, we just figured out a second or two ago, was 0.12. The bottom branch, if I multiply, I believe is 0.63, and adding those two up, you get 0.75? 0.75. All right, and then, last question. Part C. Find the probability that Joe is on time given the train was late. Okay, so given that the train was late is, let me circle some stuff. Given that the train was late is this two branches. So the top branch is I'm in a wrong color, here we go. The top branch is 0.18, the bottom branch is 0.12. Putting those together makes our denominator of 0.30, right? This is all the ways that the train was late, okay? Now that I have, again, I'm focusing in between the yellow circle. Now I want Joe to be on time, okay? Joe on time happens right here as a 0.12, which reduces to 2/5. Okay? Most important, when you see the word given, and I do tend to write it in all capitals because it's really important, it changes the denominator, right? It limits where you can look. That's all given does. Instead of looking at the whole tree, I have to look at just a very specific part of the tree.